Hello. Welcome to the final session of today, which we hope to make kind of an interesting one. This is MPEG-DASH, commercial deployments, and outlook towards HEVC and 4K. For those of you who have been here throughout the day, I'm sure this is the first panel that's ever mentioned HEVC. So we'll be having some discussion about that, but we're also very focused on Dash as an enabler moving forward. So we got panelists today. There's going to be a panel session. Hopefully we'll get some interesting questions from me, from the audience. And I'm going to do a short little introduction, topics that you probably already know about if you've actually been paying attention throughout today. But hopefully some controversial statements about what the future looks like, and some people who are key to actually rolling it out commercially and actually making the difference as we move forward. So let me do just a quick introduction. My name is Richard Doherty. I'm actually from Dolby Labs. So I'm going to talk. Everyone throws around statistics, but I picked out a couple of fun ones. But we all know consumers, 84% of them, this is how they're watching video, is they're streaming it. That's why we're all here. That's why we have jobs. That's why we're thrilled to be at this conference. We all know that YouTube is serving 13 billion videos. The average user is 401 minutes a month. I picked out a research comment that confirmed viewers, if they have to wait for more than 2 seconds, the majority of them will not watch that video. And so startup time is really key, and that's one of the advantages, of course, of adaptive bitrate video, which Dash plays right into. And they actually calculated it on a curve. Each additional second of startup delay is 5.8% of people then abandon the video. So you can actually tick and watch as your people stop watching your video. And of course, 138 years of video content cross IP networks every second by 2016. You've also seen the statistics about in the evening, by far the vast majority of IP is taken up by Netflix and our friend Hulu here. Thank you for that. And as we know, the reason that we're focused on adaptive streaming, and that's the focus of many things here today, is we like that instant start. There cannot be a startup delay. Our consumers today are no longer expecting that. We want continual and seamless adjustment to bandwidth changes, of course. That's the whole part of adaptive. We want our quality to be extremely high such that when people stream content, we are getting closer and closer to what some of us consider the gold standard with actual shipped media to consumer devices. Dash, and we'll talk about Dash. One of the advantages of Dash itself, I get into, is the fact that it can stream over normal HTTP protocols. And we want to make sure that we're streaming to all the devices out there. We know the device landscape continues to change, continues to shift towards mobile devices. And we also want the IP infrastructure that we've spent all of these years building, or others have spent years building, and we're going to spend years using it, to make sure we can use that existing IP infrastructure. But the real reason we do adaptive streaming, of course, is the horror of internet video in 2003, which was buffering. I don't know the last time you saw buffering. I still see it from time to time, depending on your IP connection. But this is the reason, the God's honest reason we are here and making sure that Dash is successful so that no one ever has to suffer through the horror of that again. I want to talk about Dash in particular. I think you guys know it. I hope you guys know it. If not, dynamic adaptive streaming over HTTP. This is a standards body implementation, and I will talk about where that came from a little bit. And again, I'm just going to introduce a few slides, just getting you to make sure we all are on the same page in terms of topics. But this is adaptive bitrate switching. So as the bitrate, the bandwidth changes between the client and the server, the video automatically changes its bit rates and therefore produces a continual, seamless, smooth experience for you. Dash supports live and on demand. As I mentioned, it ships over HTTP protocols. The nice thing is you can take one actual package, one manifest of Dash, and you can spread it across a number of CDNs. You can have some streams coming from one CDN, some from the other. You can do a number of load balancing kinds of opportunities there. And some of the people on our panel might talk about more. Fully supporting ad insertion, which is important, especially for live streams. There's the common encryption standard as part of Dash as well, which means if you're encrypting your content, you can encrypt it with a single key, and then you can use any DRM to wrap that key that you want. It's pretty cool, actually. Multiple video and audio tracks, again, to replicate as much as we can some of the gold standards. And some of the things we're going to talk about today, it's pretty much codec independent. And so we're going to talk about transition from AVC to HEVC, and very scalable. Certainly the Dash the dash specification itself doesn't have anything to do with codecs. It only has about the manifest and how things are contained. But as we move to 4K, dash as one streaming element will presumably, unless my panelists tell me differently, be right there ready to go. I do want to mention the Dash Industry Forum. It's very well represented here today. And in fact, this panel, the original idea for this panel was someone by the name of Jan Nordman from Fraunhofer, who is off hopefully having a baby in the next week or two, or his wife, if things go as normal. Dash Industry Forum, the whole point of that is to enable market assumption and promote MPEG-DASH as a standards format. But they also publish a number of interoperability points, which we'll talk about a little bit. There's the main one that they published several months ago at this point is Dash HEVC 264, a basic interoperability point, and codec specifications for that. So the idea was that we're going to take Dash, which really is just a manifest format, and we're going to make it interoperable among people. The group runs interoperability tests and liaisons with other organizations. The standards itself, MPEG-DASH, came from MPEG. That really is their logo. Is an ISO standard now, and I said what it stands for, and Dash IF being another group there. But there's many other groups working on standards right now. You guys know very well. 3GPP, OIPF, DVB, HBB-TV. Many of them have published. HBB has certainly published some specifications, which people are publishing Dash to those specifications. So the standards problem, still got a little bit of problems working out, but in fact, they're pretty darn close, and a lot of people in this room today have done significant work to make that the case. What is HEVC? Hopefully you guys have seen the panels here, so I'll just say it very, very quickly, but it's a brand new video codec. Welcome to 2013. It is the successor to H.264, and it's new coding techniques that are layered on top of H.264, so it's really evolutionary from that. It's got better compression efficiency, but depending who you hear from, or depending who you hear from even today, it's somewhere between 20%, 30%, 50%, depends on the codec, depends on the material. We don't yet know. So it's kind of interesting there, and hopefully we'll get some feedback there. Resolution supported in HEVC right now, and the existing profile is up to 8192, which we call 8K. And rollout is coming, we don't know when. If you heard from the very last panel from Avni Ramdia, she said it's not for several years and you guys should not be in a rush. I think if you heard earlier in the day from Jan Ozer, you might want to be in a rush. So we'll see and we'll talk about that. But a lot of people are implementing. A lot of people have been showing at trade shows. A lot of people showing here today in the demo suite. There's a list of companies there. Samsung and LG announced both mobile TVs and mobile devices and televisions, and their 4K televisions do in fact support HEVC. And there's at least one estimate that says 2.4 billion HEVC devices by end of 2014. Of course, the panel, the presentation last hour said that that number is kind of a lie, because if you're not multi-core, you can't decode it. So we'll talk about that a little bit. And finally, I want to mention the Dash IF profiles themselves. I mentioned Dash IF started with Dash HEVC 264. It was a baseline profile that went to 720p. It included just mandatory stereo audio, subtitles, and AVC video. And then they announced profiles and extensions for HD to up to 1080p and multi-channel audio. And then they've recently, and it's on their website available for review, doing community review for Dash HEVC 265, which also has a baseline to 720p and extensions for 1080p and extensions for 1080p 10-bit. If you're paying attention to HEVC, they have both a main profile and a main 10, and so you actually get more bit depth without actually getting more resolution at the moment. Right now, Dash IF has not specified anything in the 4K or higher resolution space. We'll get to that. What is 4K as opposed to what is HEVC? Some see them as very much linked. I do. Some people do not. Like I said, the last speaker did not. Maybe our panelists do not. Of course, 4K is really just more pixels. That's it. More resolution. You draw boxes. That makes it very visual. Most of the 4K implementations are 16 by 9 or 3840 by 2160, which of course is double in both directions of existing 1920 or 1080p. But of course, the actual HEVC profiles include thing for native DCI 4K, which actually goes to 4096 by 2160, if you care. And HEVC also talks about 8K, which is basically you double it again. And we all know NHK has showed some very beautiful images in HK, in 8K. But where do we go from here? This is part of our topic from the panel. Other than more pixels, you can go in two different directions in terms of image quality, and that's faster pixels. Higher frame rate material is coming. We've seen it in The Hobbit. Peter Jackson is shooting at 48 frames per second. I hope some of you have gotten a chance to go to the theater and see it in high frame rate. It's a different experience. Not everyone likes it. but I'm interested in your opinion. And of course, James Cameron is doing Avatar 2 at 60 frames per second coming out at the end of next year. And gaming content has, for quite some time, done much better than 24 frames per second of material. But then better pixels. Where are we going from color gamuts right now? We've been locked for 709 since HD launched. And as we know in the cinema, doing digital cinema does P3, if you guys are familiar with color gamuts, which is quite a bit bigger than, I should have put the CIE diagram, we all love those. But people in 4K are sometimes looking at Rec 2020 as a much wider color gamut. And as we move to 8K, we might go there as well. In addition to greater bit depth, which adding 10 bits or even 12 bits of color, and brighter displays. Right now, you may not have seen, or you might not sort of in your thinking, but right now video coming from Blu-ray discs is capped at 100 nits of light output. Nit is a candelabra per meter squared, if you care about the units. And cinema is about 40 nits. Digital cinema is about 40 nits. But we're looking at displays that can do 1,000 nits, 4,000 nits. The sun is 1.2 billion nits. And so there's a lot of things that you can see with your eye that you cannot see on current panels given brightness. We want to talk about advertising insertion, because it's very important to our existing business. We want to do that seamlessly, and there's many, many challenges in terms of serving it from other locations, serving it seamlessly, changing audio codecs, changing resolutions on the fly, making a good experience for the consumer, and also being able to do that to live streams as well and have those ads rotate in. And we have Hulu here today that actually knows quite a bit about that. And multi-channel audio. Once again, if we deliver things, even though we're streaming it, we want our quality to be as good as possible. We want to recreate the experience that we're getting on our optical media. And optical media has, for 14 years, been shipping 5.1 audio, and we want to make sure we keep that as well. But then we have audio switching issues as well. As you're adaptively switching image, you can adaptively switch audio as well, and we can support that. Dash certainly does. So does the Dash IS profiles. So that's about it. I just want to introduce my panelists. To my left, Baptiste Quadier, Principal Software Development Lead for Hulu. We're happy to have him. To his left is Thierry Fautier with Harmonic, and to his left is Aitak Biber from Qualcomm. It's a great panel. I'm super excited because we have both someone who's implementing it and delivering content. We have someone who's doing the encoding. And we have someone who's making the chips. It's great for us. One of the panelists had a video for us that he wanted to play, and so I'm going to quickly play that for you as an introduction. This is from Thierry Fautier from Harmonic, and that has a little bit of audio, so we'll play that.
Spanish operator Abatis Telecom required an innovative cloud-based solution to deliver on-demand services to over 15 million households.
Reaching millions of TV viewers with new interactive services such as catch-up TV and video on demand is a significant challenge in free-to-air horizontal TV markets. Connected TVs provide an innovative technology solution to address this TV anytime opportunity. However, multiple streaming and DRM technologies need to be efficiently implemented on the server platform and by the different vendors of connected TV sets. That's where standards such as HBB-TV and Dash help different vendors collaborate to speak the same language. The overall platform also needs to leverage cloud delivery technologies to scale and serve millions of TV viewers. Leading technology solutions, such as Harmonic Pro Media encoders and Nagra content protection technologies, make it possible to deliver the best content and image quality so that consumers enjoy a spectacular on-demand TV experience. This collaboration takes us to the next level in TV delivery.
All right. Let's introduce our panelists and let them get the chance to talk for a moment or two. First, I have Baptiste on my left, and so I'm going to ask you guys, just as a way of introduction, tell us, let's start with Dash. How is Dash doing? Are you deploying it? Where are you in deployment? Do you really see that as the future as opposed to, God forbid, HLS or other proprietary solutions to date? Baptiste?
Yes, we're actually using Dash in production right now and on the Google Chromecast device. And we definitely see it as the future of on-demand delivery.
Wait, sorry. 100% of your content?
It's 100% of the content. Every piece of content that you watch on Google Chromecast is using MPEG-DASH.
That's kind of cool. You guys don't know Chromecast? That's that little HDMI plug. It only costs $29, I believe.
35.
35.
This is without the Dolby royalties.
Thank you. Yes. So it's not as good then.
Do the math.
Yeah, $35. It plugs into an HDMI port. It's really, really small. Allows you to stream all the services, including Hulu. It's pretty great. All right. Well, tell us Harmonic's story about Dash and where you guys are right now.
So the good news is today France qualified for the World Cup. The bad news, this was in HLS. So I know we have French supporter. The OVF squad is watching us live. They are complaining about the sound. But more practically, so we have been deploying, for those who don't know, Europe has defined a standard called HBB-TV 1.5 for hybrid broadband TV. So it's basically all the interactivity protocol to go on the TV, and Europeans have said, okay, one single protocol for all the TV set, which is regulated by the European states, Spain, France, following Germany and others, except UK, of course, which is different standards. But the goal is to have one single stream that goes across all the TV set with embedded, basically, player from the TV manufacturer. And the dream is one stream will go across all the tablets, the PCs, the phones, and we stop this fight of different standards doing the same thing and making my company richer as opposed to making the life of consumer simpler.
And so HBB TV, that's the 1.5 standard, and they're working on 2.0, is that right?
Correct. So
Okay.
2.0 will have more features. I believe there will be more functionality around advertisement, around on-demand profile. But I would say HBB TV 1.5 is probably not too far from what Hulu is deploying today. It's a ISO BMFF live profile. And I would say it's deployed today in France. In Spain, it's in trial right now. And the goal is to get that as a given on any TV set that you purchase. You have a connected TV, you have the Dash player built in.
And, all right. ATAC, Qualcomm.
Maybe I should start with a few words on the Qualcomm in case some of the folks are not familiar with the name. Qualcomm is a US-based incorporation and is world's largest fabless semiconductor manufacturer. And it produces and delivers basically the largest amount of wireless chipsets and software technologies that powers pretty much majority of 3G, 4G devices that's commercially available today. With respect to our contribution to Dash, our involvement with Dash, we are one of the many contributors to Dash standard itself. Despite the fact that Dash being relatively new standard, what is important to note here is we are actually shipping Dash client on our devices since November of 2012. I want to emphasize that because more and more I'm realizing that the client availability coming up as one of the issues with the Dash deployment. So I just want to make sure that Qualcomm moving more than north of like 700 million devices with a decent sized footprint, we are pushing Dash out there. And this will be the fact, moving forward. So if I were to say, be more specific, we shipped Dash in our, Snapdragon platform, high-tier platform a year back. But if you take a snapshot from today, pretty much all devices that will ship in 2014 will be shipping with the Dash client. So there is no excuse about, lack of, client or, if you do it, will there be devices that can play back Dash? For actual deployment, I know at least one or two companies, I know for a fact, OEM partners of us actually deploying Dash for their own services. Unfortunately, I'm not at the liberty to, give their names and explain it. But I can tell you that Dash is happening. Maybe it's just the lack of visibility at this point.
So 100% of your chips in mobile space.
Yeah, to be more accurate, yeah, 100% in 2014. Let's put it that way.
So every cell phone and has both an AVC hardware decoder, of course, and a multi-core processor, and be able to play Dash.
Yes, from low tier to high tier.
Excellent. That's a good sign.
Hopefully.
All right, so the title of this particular panel is about where do we go in the future. So I do want to talk a little bit about HEVC, even though there's quite a bit of talk about it today, but I want to hear about the real world deployment of it. So I'd like to hear when you're going to start rolling out HEVC. Have you started already? What's your plans? Let's start, Baptiste.
HEVC is an interesting subject. Hopefully, it's going to help, I think, all across the board. And first in mobile, because that's where we have like the most constraints, in my opinion. And HEVC really enable us to go lower in bitrate. And of course, if you go lower in bitrate, you improve the quality of service, which is very important for like everybody that's streaming online right now. But it will also help at a higher resolution. And it will definitely, in my opinion, enable 4K, for example. I don't see 4K happening without HEVC right now.
So you're not rolling out any of HEVC commercially, but you're testing, is that?
We're evaluating. I mean, reasonably, we won't be streaming HEVC until we have proper hardware support. Like on mobile, it's because I think primarily battery life really matter. Mm-hmm. So it's simply, in my opinion, not possible, very difficult to have software-only implementations.
Right.
But as soon as one device in particular will support it in hardware, will definitely be present on the device.
But you say when 4K comes, you're going to need it. Is that what I get that right?
Yeah, when 4K, like when we start getting a lot of content in 4K, HEVC will definitely help us there.
All right.
Like achieve like reasonable bit rates.
So when is 4K coming to Hulu?
It will come as we get content in 4K.
So you're passing the buck, I believe it. I love it.
I mean, in movies, they already shoot in 4K, in 8K. So I believe they might start sending copies to some people.
Certainly Netflix has made some hinting announcements.
Right now, we don't have any source in 4K.
Okay.
So
let me hear from ATEC about...
on the Netflix front, I'm sure pretty much everyone knows, everyone in the conference here knows that Netflix actually went on record and they said they are looking at Netflix 4K streaming as early as 2014. And in fact, I have seen public demonstrations where Netflix folks are explaining the fact that they are working on the 4K profile. So hopefully, yeah, there will be some interesting development on that side. But going back to his earlier comment on 4K and where HEVC finds its place, I think for 4K, it's the consensus that HEVC will be almost like a requirement. I mean, today there's another deployment, Sony notably doing 4K. It's more of a video on demand service, and I believe they are using H.264, not necessarily HEVC. And I can only imagine they will move to HEVC. So, 4K HEVC, kind of like a symbiotic relationship there. If I were to, put that aside, maybe that's not an issue of Hulu, or from their perspective, they're not seeing it. But we have a problem in our hands, especially on the mobile side of things. We have carriers, coming and saying, their network is congested, right? No surprise here, and video being the primary problem that creates the congestion. So they are continuously asking, okay, how you can help, right? So for the last almost 2 years by now, we are continuously bringing the message that hey, there is this new thing, HEVC, just hang on tight. It will come in, and at that time it was more of on paper. It will give like 50% relief, which along the standardization path, we also saw that it is delivering 50%. Obviously, different efficiency at different resolutions and use cases. But what I'm trying to get to is, there is probably a play for HEVC in low resolution use cases too. So, I mentioned the mobile device scenario where you're, even doing YouTube, or it may be a carrier walled garden, video service, which is very typical with some of the big carriers. They have their own video services. So they are looking at HEVC as a relief where, they can get in the short to mid term, like 25, 30%. In fact, I see data analysts where they look at, okay, this is the amount of content that's going through. If I were to switch to HEVC with such and such device, I can get like 25% reduction in my congestion, and which they also anticipate 40 to 50 in the next wave of HEVC as encoders gets better, and the footprint of devices in their network that can play back HEVC will be bigger. Eventually, 100% of devices being able to play back HEVC, meaning 100% switch over. So there is some hope and a plan to deploy low resolution, meaning 1080p and below, on the mobile network side of things. And I have seen a couple other interesting look at HEVC. I don't know if you guys know, but Snapdragon is not only on phones, but we also power some of the set-top boxes and smart TV, which is a new business for us. And as part of this new business, we talk to pretty much major IPTV operators out there, and we see interesting use of HEVC, which is like an IPTV operator may look at HEVC to, let's say, go from standard definition to high definition, like 720p. For certain channels, not necessarily for the whole channel lineup, but maybe some select 3-4 channels to be upgraded to HD. That's some examples that I saw. Another look at is basically pushing the frame rate. I have seen especially some sports networks which are tied with the limitations of the traditional broadcast. They actually shoot their content at 60 frames per second, but because they need to exist in the broadcast infrastructure, they go down to 30 frames per second, which is something not favorable for them. So especially with over-the-top delivery, which is being a little bit more progressive, where you can set the rules. So I believe some of the folks are looking at like 60 frames per second, like 720p instead of 30, 60 frames per second. Or if it's say 1080p 24, they are looking at 48, 50 frames per second to reduce the motion blur. So cutting to the chase, not only 4K, we know 4K will happen. It's a matter of like when and in what form. And HEVC will be there, but between now and then, I think there is an opportunity for HEVC.
So
with other devices.
when in your chips might HEVC decoding be coming?
So it's funny you ask. I will be repeating what I just said with Dash. We are actually shipping HEVC decoder for a while. We demonstrated HEVC playback several times at the shows with and without Dash streaming. Obviously, it's not necessarily a hardware-accelerated solution, but for the use case and the customer profiles I just mentioned, there is a rushed, basically expedited need to deliver a HEVC solution. For that reason, we looked at a DSP-based decoder that can span across our devices. So in 2014, we are shipping HEVC decoder. Actually, since August, we are shipping HEVC decoder. And we plan to move HEVC decoder into more devices in 2014. And in the long term roadmap, obviously we are looking at supporting it in a hardware accelerated fashion, as the rest of the industry looks at.
Well, there you go, shipping already. Thierry, talk about preparing this content, HEVC, 4K, you seeing a lot of it? Are your tools ready to go? And how specifically, I mean, obviously there's a transition period, so all these guys, Hulu and people building stuff on Qualcomm chips, will have to ship both AVC encodes as well, simultaneous with HEVC decodes. Is there a way to get an MPD that packages both and sends the right streams to clients? How are you going to manage this transition for us?
Yeah. So first, to be factual, because we hear a lot here, When people talk about mobile, it's actually a mobile device. I want to break some dream, but 60 to 70% of the usage of mobile devices at home on the Wi-Fi network today.
It is 60, 70% is on Wi-Fi. Okay.
Yeah, so
and that's because it's tablet-based?
Tablet or mobile phone, but
okay.
Kids get the mobile and parents get the tablet, or the other way around, depends who has the power. But I think, to be clear, I think wireless, pure wireless streaming is a real problem, and you have people building video optimization company just to rate shape and transcode, so that's a given. HEVC is there to be a solution to a bad cure. Don't forget, this morning we had this EMBMS LTE presentation, people telling you they want to do broadcast over LTE. If you say today it's only 10 channel and tomorrow with HEVC you have 20 channel, getting more interesting. So I think on the mobile, there are good use cases. I agree with ATAC. The broadcaster are telling us 720p 30 as it is today is not broadcast quality. So I can show you here a tablet which is playing back with a visual on player 720p 60. And this is 4 hours of battery life on a Nexus 10 dual CPU. This is $399, not very expensive. So I think on tablet, we are probably there in terms of encoding, decoding capability. Of course, on mobile phone, I believe you need to have acceleration. So other use case not mentioned here because this is kind of a walled garden application, IPTV. You are going to laugh, but in some countries, like in Europe, you have one SD stream coming to the home, 3 megabits per second.
I got Time Warner cable. Nothing surprises me anymore.
So at the end of the day, those operators, they say, I would like to have an HD service. And the only way to go HD for them or to bring the second screen to the home is HEVC. So this is no-brainer. Now, when you go on 4K, I love Netflix. This is a great marketing machine. I'm going to share with you 2 numbers. Today, average ISP ingest bandwidth from Netflix traffic, 2 to 3 megabits per second. Public information of Netflix CEO, if you want 4K, it's going to be 15 megabits per second. Somebody has to explain me how you close the loop between 3 and 15. For the records, we were showing at Interbi in Japan, 4K 60 at 15 megabits with VOD encoding, very aggressive. We can get there, but the business model has to work. So I wish good luck to my colleague at Hulu. If he can run a business with 15 megabits per second, I think what Netflix doesn't tell you is that you need to use their CDN, and then it's not over the top, it's a managed service by Netflix.
They've certainly done some innovation in terms of CDN.
Very, very important for everybody to understand what is 4K, how does it fit in the network. Now, from our perspective today, our core business is MPEG-2, MPEG-2.
Yeah, I heard of it.
MPEG-4, and HEVC is a nice technology, but we need device, we need royalties. What is the MPEG-LA is doing this email?
Yes, MPEG-LA is right in the front row over there.
We need, of course, chipset that make it efficient in terms of decoding. And the content, of course, 4K, you need a library of content. So for time being, we develop the technology. We are preparing trials with operators. The main interest today, I would say, is wireless, true wireless delivery to a wireless network. IPTV operators who are really the back against the wall, they want to offer decent service. And I would say 4K, mostly VOD today, because if you read the EBU report about what is UHD profile between ITU, EBU, SMPT, is kind of a mess right now. I hope we will be able to converge 4K, like 4K resolution, 10 bits, 60 frames per second. We lock the spec for the next 3 or 5 years. And after that, Japan will come with 2020 Olympic Games, 8K, 120 frames per second, and then we go to another round of specification. But I think 4K is going to be a reality by 2016 for the Olympic Games. Of course, it will be MPEG-DASH by then. And the broadcast will still broadcast, I think, 4K, like transport stream, classical delivery, cable satellite.
Still be transport streams.
I mean, for broadcast, if you want to look at the London numbers, I mean, unicast session, I would like to see the BBC bill on the CDN. I would be very interested to know how much it costs to stream 10 million sessions 24/7. This is not cheap. Broadcast is there for some time for those kind of broadcasting.
iPlayer is very popular.
It's popular, but somebody has to pay. You know, the government is paying, so somebody, I mean, all those live events in unicast is costing a lot of money. I think this industry has some challenges. How to deliver broadcast across HTTP. There are good proposals. Cable Labs is working on that. Some startup company are working on that. So I think we have to do a good engineering work, how to match the technology, live, unicast, to make it cost effectively. Because at the end of the day, if the business model doesn't fly, I think Netflix, you will see 2014 3 movies, House of Cards, and with 10 players in the country or 100 players. But at the end, you need to scale a service. You are an operator, and I would like to ask the question to Hulu, if you want to be successful, you need to scale. It's not for 100 people that are the employees and the friend of the
And anyone who has Google Fiber, right?
You need to scale.
Yeah, absolutely. Thank you. All right, and by the way, I'll be able to take questions from the audience, but so if anybody get really fired up at the middle, go ahead and raise your hand. Let's talk about ad insertion. And especially I'm looking to you, Baptiste, to tell us about the struggles you've had with ad insertion and where do we go from here and what do we still need to accomplish?
So right now, let's take the Chromecast example. There we chose the double player approach because we were not like really ready to have it inline. As you know, like Dash allows you to like present media in 2 forms, or actually 3 forms. The first form is segment-based. That is the new Dash form that we actually chose to package our content with. And there's the segment timeline approach, which is the smooth streaming approach, and the segment list, which is the HLS approach, basically. So Dash is, like, supports all these 3 methods. And obviously, the segment list has many advantages on like low memory devices and like devices that actually can't like allocate 2 video players. So for these devices, we're definitely gearing toward using segment list. And on the other platforms, we tend to prefer the 2-player approach because it allows us to be like more dynamic in terms of ad choice. But we still like use Dash for all that content.
Are you doing any live streams? I don't think you are, right?
We've done some events in live already, and but not with using Dash.
Okay.
But we plan to. I mean,
Okay.
I think we have live as projects, and it's very interesting, and Dash will enable us to be efficient in that service.
Are you still doing HLS streams as well? I assume you are, of course.
We are, well, the great thing about Dash and why we're pushing it is that it allows us to reuse the same files for multiple devices. Unfortunately, we'll have to do support HLS for a long time because, I mean, iOS device in the wild, and we haven't seen any like efforts from Apple to support Dash.
Right.
But I'd say except these devices, we will be able to use Dash everywhere. And that's really where the Dash strength is, in my opinion.
One of the questions I had for you guys was, we are seeing Netflix pushing into 4K, pushing into Super HD, trying to make a lot of statements around quality, which I think, and I agree with you, you correctly assert, they don't have the bandwidth really to ship these to even a large percentage of their customers. Even Super HD is, what, 8, 9 megabits per second, something like that. But they believe that differentiating based on quality of image is really critical. Is that something that you see as well, or is it all about mobile? Is it all about maximizing bandwidth to get the maximum number of channels? You know, where is our attention in terms of?
Well, I would say for Netflix, I think the majority, if you look at the client usage, is a lot of TV viewing. what we know from the tests we do in our labs is a very good 1080p 60 sequence encoded at a very high bit rate on a very good upconverted TV. You ask people, is it 4K, is it not 4K? You make A/B blind test. Most of people don't see a difference. So it's true that there will be a transition in the industry with 1080p 60, which, by the way, is completely standardized. People have this in the production studio. It can flow to a network. We encode it today. So this is a good intermediate step. And of course, you need a UHD set-top box to upconvert to a UHD screen. So it's not going to happen today, but maybe tomorrow.
So you're saying the primary use of a 4K television is just upconversion?
Of course. I mean, read the Sony press release. There's no network connectivity. And even the Sony box is 4K 30. It's not broadcast. So also people need to understand there is the 4K 24, the movie, 4K 30 HDMI 1.4, 4K 60 broadcast production format that nobody today can decode. We were the first one to demonstrate, actually, a 4K 60 to a TV in Japan on the DisplayPort 1.2. But this is a lot of work to encode, to find the right player, the right connectivity to the right TV. But this is what you'll see at CES.
I don't know if you guys have seen the Sony 4K television in Best Buy. If you go there and buy it, then they will sell you next to it is something that looks like a Roomba, which contains 10 4K movies from Sony Pictures that they will sell you alongside it. And then they continually refresh those 10 movies as a download.
So this is 40 megabits per second encoding. Try to stream that on your 3 megabits connectivity with ISP, and you let me know what you get.
Well, I heard the harmonic encoder is really, really good.
No. It's the laws of physics. 40 megs in a 3 meg pipe is like 10 hours to download the movie. That's not a harmonic encoder.
Maybe I can give some color on the 4K, at least from my perspective. That first of all, it's a matter of the timing too. If I was answering this question a year ago, I may have a different answer, a different take on this. But I would say, right now for 4K, I have a little bit more bullish view. We will wait and see. This is due to the fact that this past year, there were a few maybe disruptive, changes with respect to 4K. What happened is, we saw a big, price erosion of 4K panels. It turns out, actually, building 4K panels are not, exponentially more expensive. And China demonstrated that. Not necessarily the best TVs, best breed out there, but there are a lot of TVs that will ship between now and 2017 that will be in 4K. In fact, one of the Chinese vendors, I met just a couple weeks last week, said that more than 30% of their production will be 4K in 2014. Similar report, one of the Japanese vendors, not my interview, but I saw this on public domain. They are estimating like over 60-inch, 50% of their production will be 4K. So what is happening is basically China introducing really low cost 4K TVs, which is applying some downward price pressure on the A-tier companies. So we will, if you are interested, you will get more and more plenty choices of 4K TVs. So the panels, the TVs were a problem, right? Back then, for example, we actually at Qualcomm we bought like 2 Sony TVs 2 years ago, which I will explain why, and it was like $25,000. It was like VIP delivered, right? Someone actually bringing in, setting it up. It was, obviously out of reach for many, many people. But now we are talking about like, $5,000 in only 1 year. And probably, next year, the price, delta between a 1080p decent television versus, 4K, it can be as low as, $500. So why not, my next purchase, shouldn't be, 4K, right? Call it future proofing. So there is the price erosion. There is, consumer electronics, doing a full assault on 4K. If you walk, CES, NAB, IFA shows, giving names like Samsung, Sony. I mean, there is an assault of 4K marketing campaign, right? I would even say like for some of them, it is act of survival. This is the last thing they need to hang on to. They can kind of bring their
So, I mean, the question is, to Thierry's point, they're going to sell these 4K TVs, and I agree, they seem to be pushing them in the channel very aggressively.
What service?
What do you watch?
Yeah.
But that's the third aspect which I want to mention this, and I want to take some credit for that, which is actually Qualcomm's latest Snapdragon platform, Snapdragon 800, which is already in Samsung Galaxy Note 3, captures and plays back 4K today. Okay, so if you go to any store in any part of the world, grab a Galaxy Note 3, and there will be several other phones. Not it's a special feature of Note 3. You will be able to capture and play back 4K on a mobile device, on your everyday device, right? So if someone says, where is the content? Yeah, there is. We can talk about the studios, their plan, the monetization, etc. But these folks will be the 4K producers, right? Next thing, you will see, instead of 10 clips, you will have, God knows, thousands of clips that will be in 4K.
So that's intriguing. So user-generated content might be a driver, because we look at the HD transition, right? It was largely about broadcast, right?
Why not? If the availability is there, if if your mobile platform supports it, readily available in your pocket, and it's a debate between myself and my wife. Actually, she goes, says that a lower resolution, thinking that we will not print out, but I go, say set it up at the highest resolution, because who knows? I may print it out, right? So similar to that, if my device is capable of 4K, I may not have a 4K TV, but why not? I don't future-proof my digital memories, that things that matter to me, things that are personal to me, right? The fact that I can capture it in 4K, play back at a lower resolution, enjoy today, but when I have the 4K TV 2 years later, I will watch it in 4K. So I just want to mention that Snapdragon 800 and is something that we introduced 4K playback. Probably that's the universe's first 4K capture and playback on a mobile device, and stay tuned.
That's really interesting. Thierry, you want to jump in?
Well, yeah, I mean, the TV guys, they have told us the 3D story. Everybody knows the conclusion. They have told us the connected TV portals they are building. We all know the conclusion for that. So they come back with 4K. I would like to take that with a grain of salt. I think what will make people buy 4K TVs is to deliver 4K services, meaning content, encoders, network, business model, security, audio.
But you just told me it's going to take forever.
It's going to take time. How many years HD took? And you had government with a stick saying to broadcaster, you don't broadcast HD, I take your license out. So who is forcing today content, broadcaster, service provider? I think what is for us a low-hanging fruit 4K application is this library of movies in 4K that you put on a VOD server or NVOD service in satellite and even cable. And you can do great delivery in broadcast or in unicast. Satellite operators are telling me I have no customer on 4K. It will be VOD.
So you touched on something else I do want to ask questions about, which is about security. Not just the DRM, and we talked about the common encryption that's part of DASH standard, but other additional security. Movie Labs published a document that from the studio, additional requirements as we move to 4K, there are going to be additional security requirements. Yes. Are you looking at that?
Yes, we do. And the bar is going to be higher. It will be, of course, common encryption, DRM, watermarking, IP address, VLANs, HTTPS is going to be hyper secure for the content provider. Basically, they give you the master format. And before, you ask HBO if they give you the master format like this.
Atech, what do you think about security?
For security, I guess, probably I don't have much to add, not being a security expert myself. But I know for a fact that as the value of the content goes up, and I would imagine that's the case with the 4K, the content, the security, the rules, regulations, the strictness will go up as well. I believe for ultraviolet, there's already a consortium one of my colleagues is looking into. To address particularly that, how they can protect, 4K content,
and
storage content.
Baptiste, you have the advantage you were started by studios, so you were sort of de facto grandfathered in, but
well, it helps sometimes, but it doesn't really help with security. I think content partners really want to protect their content now, and they're really knowledgeable. So they're really pushing for full DRM solutions starting now. Nothing will be unencrypted. Nothing will be non-secure. They really insist of having a full decryption path that is keeping the key secure. The video data should not leave a trusted code path. They're really full security right now. And we're talking about 1080 only. So imagine what kind of security they will want for 4K.
yes.
They will want HDMI next version.
HDMI version 2.2 is specified in the Movie Labs document.
2.1.
That's what they will want. And
2.2.
Yeah.
they won't allow you to stream HD on non-hardware protected devices.
Right.
And so on and so on. I think all across the board this is happening from all content partners. So this is the reality.
I do need to, because I'm paid, to ask you about multi-channel audio and about delivering those experiences. Where are you guys there? Are you seeing that as a necessary part of your deployments?
So on the Qualcomm side of things, we have support for pretty much all multi-channel audio standards. You name it, either AAC, Dolby, DTS. Obviously, we don't support everything, in the context of Dash. We look at Dash interoperability points as our, design guideline, and so far we support, AAC, for example. But what I'm getting to is, when Dolby DTS, becomes a part of the interoperability point, certainly, we have the native playback capability on devices that we ship. I don't know which particular, what tier, but at least for the mid to high tier, a good volume of devices, either on the smartphone, tablet, smart TVs, we do have the capability on the devices.
Okay, and I know Dash IF specifies it as an extension. HPP TV specifies it as a part of their specification. Happy to help if you need it.
Okay.
Baptiste,
There's some demand for 5.1 audio. Some content definitely benefit from it. I think the main problem is like which device and how we're going to transport it. Dash definitely helps here, as it's codec agnostic. So definitely we won't do multi-channel audio without Dash today, and it will allow us to seamlessly fall back on a stereo track for devices that don't support 5.1 at all. I think that's where we are.
Okay.
We need multi-channel audio, for sure, and adaptive streaming multi-channel audio, not a la Apple single bit rate from 100K to 10 meg. This is not a starter, I think. So we welcome innovation on audio.
Any questions from the audience? Oh, there are some. Let me start back here, please. Yes, use a microphone if you would. And if you have other questions, if you want to, form a line or something so that there's not a delay.
Balakrishnan, River Silica. How do you deal with 5.1 when you've decoded it on a mobile?
I guess this
I guess I could speak to that.
Oh, well,
yes.
Yeah, I mean, for example, with Dolby Digital Plus, our audio codec 5.1 automatically can down convert to stereo and can do it in a way that's dependent on either your headphones or the speakers that are in your tablet. I mean, the filters are built in.
So it knows what the target hardware is.
Exactly right.
Or that you're streaming it to your sound system.
It knows that, yes, you're plugged into HDMI, and sort of the certified decoders do this automatically. I think the other audio codecs do a similar thing. And then, obviously, as part of Dash IF, HEVC V2 is actually sort of always a fallback as to get that stereo experience.
Thank you.
And in fact, Dolby streams 7.1 audio on Voodoo, for example, so we're pretty active in the streaming area there. You had a question?
A question for Baptiste. I know you say you're using Dash on Chromecast. I was wondering if you're using the Dash.js player or if you've created your own player for that.
We actually wrote our own player, as long as the browser export the necessary functions to be able to.
Is there any reason you didn't explore the use of Dash.js?
No. I mean,
okay.
This is also for Baptiste. So since you've worked with HLS and now you've also worked with Dash, what's your comparison between HLS and Dash in ease of use for developing for, as also its performance between HLS and Dash?
Good question. First, I think the main advantage of Dash is that it's an ISO standard. It's based on MP4. You have a lot of great tools that can deal with MP4 today. Dash supports, I think we can say, every DRM that is in existence today. So it's really the key for us to save cost on storage and be able to address as many devices as we can. Also, it's very easy to put a smooth streaming layer on top of your Dash files, so you can both address your smooth streaming device and the Dash native device using the same files. I think this is really the Dash strength here. It's multi-DRM, codec agnostic. It's definitely the future.
Any other questions? Please.
Hi. As it relates to MPEG-DASH and any of the future standards, do you see the opportunity for these standards to reduce the bandwidth consumption needed to deliver media, or do you think longer term, the standards will be focused more on optimization of the interface and not so much on compression?
Is it for me?
I think it was an open question.
So is it a question about the codec? Are you asking, is it a codec or transport?
Just the focus, whether the focus of future standards will be on compressing the amount of data used versus, actually just trying to create a better user interface.
So do we think we're going to use, as I can restate it, use the additional bandwidth from compression to simply save bits or to improve quality or services?
So I think from our perspective, there are two use cases of better compression. Is same bit rate, higher quality, and especially from 720p 30 to 720p 60. Second use case is lower bandwidth, mostly to provide better reach, like people today on 3G, some of the phones or the device cannot get decent quality. So if you divide by 2 the bandwidth, you get much better quality. I think nobody wants to give the streams to somebody else. It's more about the operator making more efficient. I mean, you can give your.
I think you said it well. It's all about economics. If you can spend less money on CDN cost, I mean, you're good.
CDN cost is a key. I mean, think about London Olympics, how many petabytes were streamed. If you can divide by 2, it's so nice. But what happens is that you get higher resolution, and the 4K is not helping there. So CDN is a good business at the end of the day. They always win. I think it's a trade-off between the device, the maturity of the technology, the network, what the content guys. I can tell you when we show 720p 60 to sports content provider, as soon as the device will be available, they will mandate this device only can play my content.
Any other questions today? I don't want to keep you from cocktail hour. I think that was it. I want to thank you guys for coming today, and thanks for watching the panel. Thank you, guys.